In this video, we'll discuss momentum. Let's read these words. The momentum of an object measures how hard it is to stop the object. So here, this object, the ball, is going to roll in this direction, and this football player is going to try to stop it. If we say this ball has more momentum, then it'll be harder for him to stop it. If it has less momentum, it'll be easier for him to stop it. Let's examine what affects an object's momentum. We have two situations, A and B here. It's the same velocity, isn't it? But what's different? The mass. This one here is twice the mass of this one. Which ball will be harder to stop? Which will have more momentum, A or B? Well, you didn't pause 1 second before you answered A because obviously there's more mass here, isn't it? It's harder to stop this larger, more massive ball. So this ball here has greater momentum because it has greater mass. The second example shows two balls with the same mass, and that's not going to be the thing that decides one having more momentum. What will? Oh, the speeds, the velocity. So this one here is the same mass as that one. It's playing faster. He's obviously got more momentum. He's harder to stop. This ball here has greater momentum now because it has greater velocity. So it seems like two things affect momentum of an object. The object's mass and the object's velocity. And that leads us to a very simple formula. P equals mv. Here's your mass, one of the factors. Here's your velocity, your second factor. Now, this is a very simple formula. It's a little unfortunate, though. We can't use an m for momentum. Rather, we have to use little p, lowercase p. That's a bit unfortunate. Also, when you do a calculation, let's say we have mass of 5, velocity of 12, plus momentum. There's your formula. Fill it in. You get 60. And unfortunately, the unit of measure is kind of crazy, too. A little cumbersome, perhaps. It's kilogram meters per second. Now, calculating momentum is one of the easiest things we'll ever do in physics. It's easy on your MCAS. The only tricky part are these symbols. P, not M, for momentum. And this one here is a little cumbersome too. Alright, so a couple of problems here. Let's see. An 800 kilogram motorcycle is traveling 40 meters per second. 800 kilograms is your mass. The velocity is 40 meters per second. What's the bike's momentum? That's your question mark. There's your formula. Fill it in. And momentum P is 32,000 kilogram meters per second. Couldn't be easier. Of course, you may be asked to solve for something other than momentum, so let's see how that works. A 400 kilogram horse, that's the mass, has 6,000 kilogram meters per second of momentum. Oh, they give you the momentum. What are they looking for? They're looking for velocity. That's fine. We'll still use our same formula, but this time we plug this in over here, and we're going to solve for V, and we'll get 15 meters per second. Now that's about it for the basics of momentum. I just want to point one thing out before I leave. Did you notice that in doing these calculations, I used a blue sheet method? I didn't use a blue sheet like this because we can't use that on the MCAS test. But didn't I do it exactly the same way? Line these things up, including your question mark, find the formula, fill in and solve. Solve from that if you need to. Sure, I did. And you really need to do that on your MCAS too. There's plenty of white space on your pages. Down beneath your problems, you can do this right like this. Use these three things here to find your formula. Use the blue sheet method. Please. Bye.